All right, nerdlings, welcome back. Yeah, you missed me? Of course you did. So today we're going to start talking about solving radical equations, which is not nearly as rad as it sounds. But anyway, it's kind of fun. So if we're going to go and solve radical equations, what that really means is we're solving equations that happen to have radicals in them. For this class, that's pretty much going to mean like square roots. So we're solving equations with radicals or square roots in them. How are we going to go about doing that? Well, first, we're going to try and isolate the radical if that's possible. It may not always be possible, but if there's only one radical, we can isolate it, and we should do the mathematical steps necessary to make that happen. If you can't isolate the radical, that normally means there's like more than one of them. Okay? And if there's more than one, can you kill two birds with one stone? Can you still just go and, like, I don't know, find a way to get rid of it and it gets rid of more than one radical? Could be. Um, if you can't isolate the radical because there's more than one of them, can you eliminate one at a time? So that's what we might call an ugly problem that we'll definitely go and take a look at a later point in time, but probably not today. So then what we're going to do is we're going to use exponents to undo the radical. Again, we're just using inverse operations there. And once we've eliminated the fact that there's a radical there, then we just have some type of equation. The equation could be linear, in which case we would just solve it using any method that we know of to solve a linear equation. But it could also be quadratic. Remember, because we're squaring stuff to get rid of square roots. So if it ends up being quadratic, then we can either factor, we can use the quadratic formula, we can do something to go and solve for it. And then once we get done with all of that, we need to go and check for extraneous solutions, because we may be able to find something that works algebraically, but it doesn't actually work. So essentially what we're looking for is to make sure that the square root of something doesn't equal a negative, while also making sure that we don't end up with a negative underneath the radical, because then we'd have something that was imaginary, and that can't be a real solution, can it? So we're going to go and take a look at about 5 example problems that are going to kind of walk us through each of the different possibilities. So the first one that we're going to look at is this example 1, which says 5 equals the square root of x plus 2 minus 4. So looking at this problem, you can tell that it is a radical equation. Because it has an equal sign, it's an equation. And because it has a radical in it, it is a radical equation. So what do I need to do to solve this? Well, I need to isolate the radically part. Okay, so all of this needs to stay. Everything that's not in this box gots to go. Okay, so maybe I need to go and add 4 to each side. Okay, so that's going to end up giving me 9 equals the square root of x plus 2. So now, is the radical part totally isolated? Yes, because there's only a single radical that's on this side of the equation. So I'm going to eliminate that radical by squaring it. And the golden rule of algebra, what you do to one side, you got to do to both sides. So we'll go and square both sides. So a square and a square root eliminate each other. 9 squared is 81, and that will equal just x plus 2. Trying to get that x all by itself means that I need to subtract 2 from each side. So I'm going to end up with 79 equals x. So I think that's my solution, but I need to go and check it, okay? I always have to go and check these types of problems. So if I plug in 79, I'm asking the question, is 5 in fact equal to the square root of 79, because that's representing our x here, plus 2 minus 4? Well, 72 plus 9 is 81. The square root of 81 is 9. So I'm asking, is 5 equal to 81 minus 4? Sorry, not 81. What's the square root? 9. Silly math teacher. So does 5 equal 9 minus 4? It sure does. So this answer is verified. It checks out. There you go. All right, so let's go ahead and take a look at the next problem. This one, fractions. Doesn't really matter. Same kind of thing. So we have 2 times the square root of 1/4 x equals 8. Again, looking at this, I can tell it's a radical equation because it has an equal sign and it has a radical. I just have the 1, so that makes things easier. So I need to isolate it, which means I got to get rid of this 2. Well, how is this 2 connected to the radical? By multiplication. It's 2 times the square root of 1/4 x. So how do you break that multiplication? Inverse operation. Just do some division. Divide both sides by 2. 2 over 2 reduces to 1. So I just have the square root of 1/4 x, and that'll equal half of 8, which is 4. And now I have the square root totally by itself. So guess what I get to do? Square both sides. Yay! All right, so a square and a square root, gone. So I have 1/4 x equals 4 squared, which is 16. So I got to get the x by itself. It's being multiplied by 1/4, which is really being divided by 4. So what's kind of the opposite of that? Well, multiply it by 4. Okay, so 1/4 times 4 is just 1, so that's 1x. 16 times 4 is 64, so that's what I'm pretty sure the answer is going to be. But before I can put a feather in it, let's go and check it. Okay, so I'm going to ask the question, is 2 times the square root of 1/4 times 64, because that's what 1/4 x really is, right? Okay, so I'll throw it in parentheses to make it look nicer. Does that actually equal 8? Well, 1/4 of 64 is 16. So 2 times the square root of 16, does that equal 8? Well, the square root of 16 is 4. So is 2 times 4 equal to 8? Sure is. So 64 checks out. That's got to be the solution. Let's take a look at number 3. In example number 3 here, we have the square root of 2x minus 7 equals the square root of 4x plus 1. So in this problem, I have multiple square roots. There's one here, there's one here. There's 2 of them. Because there's more than one, I cannot isolate. Okay? Isolate means just one. There's more than one. So this is where we have to go back and think, can I kill 2 birds with 1 stone? If this is the square root of something, and this is the square root of something, and ultimately I need to get those x's out of the square roots, well, couldn't I just go and at the same time get them both out of the square root? Probably, if I square both sides, because I'm doing the same mathematical operation to both sides, so it's mathematically legit. And when I do that, squares and square roots are inverses. So this problem is literally just 2x minus 7 equals 4x plus 1. Okay? So this is a real simple linear equation, right? We're trying to get the x's all to one side, so I'm going to subtract 2x from each side. Then we're going to go through and take 1 away from each side, and that's going to give us negative 8 equals 2x, because 4x minus 2x is 2x. And then I can go and divide both sides by 2, and I get negative 4 equals x. So I think that's what the answer is. Just like all the other ones, you need to make sure that we're going and checking it. So let's plug in negative 4. So we had the square root of 2 times negative 4 minus 7. So let's put our negative 4 in there. And I'm asking, is that the same thing as the square root of 4 times negative 4 plus 1? Okay? So if I go and start plugging all this fun stuff in, 2 times negative 4 is negative 8. Negative 8 minus 7 is negative 15. So I have the square root of negative 15. Okay? And over here, 4 times negative 4 is negative 15, or sorry, negative 16. Negative 16 plus 1 is negative 15. So this is where things get a little bit cattywampus. So is the square root of negative 15 equal to the square root of negative 15? Well, technically, yes, but those are both imaginary numbers, okay? And because they're imaginary numbers, this is what we would call a non-real solution. So if it's a non-real solution, because we ended up with negative numbers inside the radical, implying that they're imaginary. So if it's a non-real solution, it's also not really a solution. So we would actually go through and say this is not a solution because this is extraneous. And because it's extraneous, we would really say that it has no solution. Okay? So at this point, even though we can go through and we can find something algebraically, when we plug it in and check, we realize that something's a little off about what that solution is going to be. So it's a non-real solution, so it's not really a solution. But I also want you guys to remember that when we're dealing with solving equations, we could do them graphically. Okay, we could graph the square root of 2x minus 7. We could graph the square root of 4x plus 1. And you'll see that those two never actually intersect each other. Okay, now if they kept going into the imaginary plane, they would, but then they're kind of like imaginary touching, which isn't really touching, so that's why they don't have a real solution. Okay, so this is just kind of to help illustrate that sometimes you can go through and you can do all the algebra and things can make sense and it can look like it's going to work out, but then you go to check it and you're like, something's a little off. Okay, so that's extraneous. It doesn't really count. And the actual answer here is that it has no solution. All right, so halfway done. Now we're going to take a look at this one, which looks really simple, but hopefully you're going to realize pretty quickly what the little curveball here is. So this one is the square root of 8x, and it equals x. So is it an equation? Yep. Is it a radical equation? Yep. So let's go through and isolate the radical. Cool. It's already been isolated. So now I'm going to use an exponent to go and get rid of that. So I'm just going to go ahead and square both sides. Squaring a square root, those are inverses. So we end up with just 8x equals x squared. Well, if I looky here, what do we have? We have an x and it's squared. What type of equation is it when we have a variable squared? It's a quadratic. How do you solve all quadratic equations? You set them equal to 0. So I'm going to need to go through and subtract 8x from each side so that this quadratic equation can be set equal to 0. So 0 is going to equal x squared minus 8x. So now I get to go and solve this. Well, I can solve it by using the quadratic formula. I can solve it by factoring. I think the easier one is going to be solving it by factoring. So I'm going to factor this by looking at the GCF, okay? It's not a trinomial, so I can't really find factors of C that add up to B or whatever. So I'm just going to take out a GCF of x. So it's x times x minus 8, right? That's still set equal to 0. So I can use the zero product property, and I can take each one of these factors, x and x minus 8, and set each one of them equal to 0. So x is going to equal 0 when x equals 0. X minus 8 is going to equal 0 when x is positive 8. So I actually have two solutions here. So I have x equals, the smaller one is 0, the larger one is 8. So that means that I'm going to have to go through and check two answers. Okay? So first I'm going to check 0. The square root of 8 times 0, will that equal 0? Well, yeah, the square root of 0 is 0. That one works. I also check 8. So is the square root of 8 times 8 equal to 8? Well, if this isn't a picturesque definition of what a square root actually means, I don't know what is. 8 times 8 is 64. The square root of 64 is 8. So that one also works. Okay? So we have two solutions for this one, which kind of makes sense because we ended up with a quadratic, right? Just mas. So for this one, it's going to look kind of similar. because we have a variable that is both inside the radical as well as being outside the radical. So that's kind of a giveaway that you're going to end up with some sort of quadratic-y looking guy, right? But just like always, I'm going to look at this and realize that it's an equation. It's a radical equation because it has a radical in the equation. So I need to isolate it. Haha, it's already isolated. Lucky duck me. Now I need to go and use exponents to eliminate these radicals. So I'm going to go ahead and take the liberty of squaring each side. And I'm going to end up with a quadratic again. Oh well. So x squared is going to equal 3x plus 10. Since those are inverses undo each other. And again, I'm ending up with a quadratic. And because I've got a quadratic, I want to set it equal to 0. So x squared, subtract the 3x to move it to the left, subtract the 10 to move it to the left, and you're left with 0 on the right. Okay. Now this is a quadratic trinomial, 3 terms, with a leading coefficient of 1. So I'm probably going to want to try to factor it before I would even attempt thinking about using the quadratic formula. So are there factors in negative 10 that add up to negative 3? Sure, negative 5 and 2. Factors of x squared are really just x and x. So I got x minus 5, and I've also got an x plus 2. Okay, so each one of those I can set equal to 0. So x minus 5 will equal 0 when x is 5. X plus 2 will equal 0 when x is negative 2. All right, but I got to check it. Okay, because right now I'm looking at a solution set where x equals negative 2 or 5. Okay, but I got to check it. Make sure everything works. So let's plug in negative 2 first. So first I have negative 2. Does that equal the square root of 3 times negative 2 plus 10? Okay, and right off the bat, you should realize that something's not right about this one, because the square root of something equals a negative number. That's literally impossible. Mathematically cannot happen. If you kept trying to go through and do this, you'd end up with negative 2 equals the square root of 4, but the square root of 4 is positive 2, not negative 2. Okay, so this one does not work. So it is what we call extraneous. So negative 2 is a non-real solution, so it's not really a solution. You cannot have a radical equal to a negative. Right? So now let's go through and check 5. So let's see, does 5 equal the square root of 3 times 5 plus 10? Well, 15 plus 10 is 25. So is 5 equal to the square root of 25? That one is, so that one works. So our only solution here is that x equals 5. Okay? So sometimes you end up with both of the zeros that go through and work. Sometimes you end up with one and then the other. Other times you may end up with, nothing really working at all. Okay? It all depends on the problem. Each one is going to be a little bit different. Right? The last one we're going to look at is just a little bit more complicated because you'll notice we have ourselves a binomial here. Right? But other than that, the process for solving the problem is exactly the same. First, I'm going to recognize that I have an equation because of an equal sign and that it's radical. Okay, my radical is already all by itself over here on the left-hand side. There is nothing that is not a radical on the left-hand side. So I need to get rid of that radical, and I do it by squaring. But what I do to the left side, I also have to do to the right. But in this case, I'm having to go and square a binomial. So hopefully we remember that when you square a square root, they're inverse operations and they just go away. So 16 minus 5x is going to equal, but this is really x minus 2 times x minus 2. Okay, so this is going to be equal to x squared minus 4x plus 4. Where did I get that from? Using the distributive property over here, right? I trust that you guys can handle that level of mathematics. So then we're going to look and realize that we do in fact have ourselves a little quadratic guy over here, so it's time to go through and get everything set equal to 0. All right, so I'm going to subtract 16 from both sides, and I'm going to go and add 5x. Okay, and I'm doing it this way because this is a quadratic and it needs to be set equal to 0. So 0 equals x squared plus x minus 12. So this is a quadratic trinomial with a leading coefficient of 1. So are there factors in negative 12 that add up to 1? Sure. 4 and negative 3. So this is going to factor into x plus 4 times x minus 3, which of course is still equal to 0. So I can now go over here and say that x will be equal to negative 4 and positive 3. Okay. Negative 4 from this binomial factor, positive 3 from this binomial factor. But as always, got to check it. If I go through and check negative 4, I got the square root of 16 minus 5 times negative 4. And I'm asking if that's equal to negative 4 minus 2. Well, right off the bat, I know that that's not going to work, because negative 4 minus 2 is negative 6. The square root of something cannot be equal to a negative. That is extraneous. Okay, it is not part of your solution set. All right, could you go through and figure out that negative 5 and negative 4 is 20, 16 and 20 is 36, and the square root of 36, you can't really say it's negative 6? Yep, you could go and do that work, or you could recognize that this just isn't going to happen for you. All right, checking the value of 3, we could go and say 16 minus 5 times 3, is that equal to 3 minus 2? Well, 5 and 3 is 15, 16 minus 15 is 1, so is the square root of 1 equal to 1? It is. So this would represent our only solution, right? So we've kind of gone through and done an example of all the different ways or types of problems that you guys could go through and see, okay? Just keep in mind that we're solving radical equations, so we need to always try and isolate the radical if it's possible. If it's not possible, because there's more than one, can you just square the whole frickin' problem and then not have any to deal with? Or can we go through and eliminate one at a time? That'll really be what we're going to take a look at next, okay? Once we've done all that, we're going to use exponents to undo the radical, so we're going to square a square root. Then we can solve the equation, whether it's linear, quadratic, whatever, and then check for extraneous solutions, right? So you should be pretty well equipped to go through and handle almost all of the homework for today. Like I said, we're going to go and do some of these eliminating one at a time ones during our next class. But other than that, you guys should be good to go.